Good morning, everybody, or almost noon, everybody. So I'd like to welcome you to my presentation today on Apian. So my name is Keith Salzman, and I'm one of the engineering leads at Consensus Mesh R&D. So a little about myself. I usually work within the topics of zero knowledge, kind of general blockchain development, quick prototyping of solutions that have to do with newly made bleeding edge tech, and now more recently the gaming space. So before I really begin, I have to kind of give a little disclaimer that I am not the brain behind Apian. That the chief engineer, who is also part of Consensus R&D, Jim Barry, is behind Apian, and he is a veteran in the game development space. He's been at Consensus for about 8 years now. He is the co-founder of Virtue Poker, and like I said, he works in our research and development unit. So today, I'm going to do a couple things. First, I'm going to start out and I'm going to retrace the path that our chief engineer, Jim Barry, took in kind of discovering and creating the Apian framework. Then I'm going to, on a high level, give you an understanding of how Apian works under the hood. And then lastly, we're going to see a demo of a game that's made with the Apian framework that I'm going to play here on the screen with some various anonymous people out in the crowd, okay? There's one of the anonymous people. No, stop raising your hands, you're anonymous. Okay, so without further ado, this is Apian, a flexible peer-to-peer framework for blockchain games. Okay, so Apian kind of began with a single idea, and that idea you see here on the screen. So it should be practical for a single developer or a small team to create and deploy this first-class multiplayer game without a centralized server. So really quick, I'm going to dissect this kind of one-liner here of Apian. I'm in front. I should walk over there. All right, so the first part, there's really three important things here. It has to be practical for single developers and a small team to create and deploy this kind of first-class game. So with Apian framework, we are attempting to activate the community of single and small developers to give them the ability to deploy what we call this first-class multiplayer game. So for the purpose of this presentation, you can think of first-class multiplayer game as kind of those high-tier, really smooth, high-interaction, FPS, MOBAs, whatever game you love, Fortnite, Apex, League of Legends, whatever the new thing is. And then lastly, we want to be able to do this without a centralized server, and we'll get into the real reasoning behind that. But it kind of suffices to say in a nutshell that in doing so, we're going to take some of lower the barrier of entry from these small teams by moving to a decentralized framework. So the Apian team, in trying to take this prompt and create a framework, started with solving the problem of the centralized server, or wanting the lack of a centralized server. And of course, there's a very natural solution to this, right? Use blockchain as a trustless decentralized server with usage-based costs. So the idea here, the initial idea is, if the Apian framework can give a set of tools to the single small team developers that will allow them to create a game on-chain using decentralization, this will kind of inherently lower that barrier of entry. And this is going to be a theme throughout the presentation of let's lower that barrier of entry for them, right? No longer do they have to spin up and deploy this production server with this game server logic and storage. Part of that can be moved to on-chain, and just in addition, we gain kind of an in-game consensus in an immutable fashion, right? So a little bonus extra there, right? But of course, blockchain is not without its own barriers. So in an attempt to solve that first, let's do it without centralization barrier, we somewhat intentionally create other barriers. So we're going to look at what those main barriers are as the Apian team saw them that needed to be solved to bring us to a place where we fulfill that initial one-liner, okay? So really, we've divided those into kind of three big ones that I'll discuss. We have all of them come from this idea of block time batching, which results in performance and ordering issues, right? The first one here, all transactions are unlimitable to the next whole block is broadcast. Well, if you think about it, this is a very obvious problem if we want to create that first-class, high-interaction multiplayer game, right? In practice, these games, in reality, would really need to wait until that next block to even use the effective outcome of the transactions. And in trying to attempt to achieve that smooth, high-class game, well, the throughput just doesn't work as it is, right? The next one, transactions from multiple accounts are not ordered at all. So although we may be able to guarantee that a single user, a single player game, that their transactions will be ordered on-chain, but there's no guarantee that multiple users all playing the same game together, that the way their transactions are placed on chain will be in order. And keep in mind, we're talking about this really smooth game. First-person shooter, every action, every bullet, whatever it is a transaction on chain. So without the guarantee that they are in order, well, obviously, there may be some major type of drift in each person's client, and how things occur throughout the game may be seen differently through each player, right? And then once the drift is synced, well, who knows? Maybe you thought you shot another player, and in fact, you were the one that was shot, right? The last one here, on-chain cycles and storage are too expensive for casual use. Well, we're all very aware of this, right? We are attempting to lower the barrier of entry. We took away that idea of you having to spin up your own production game server. That lowers the barrier of entry. You don't need the money. You don't need the people capable of doing that. But we've in some way kind of shifted that expense over to on-chain. And who covers that expense? Well, we're not attempting to answer that question yet. We're just saying this is a barrier, and it's still blocking those small teams, single devs. And you may be thinking at this point, all right, well, we've seen some cool stuff recently. What about doing things on L2 execution chains? What about scalability, rollups, optimistic ZK, everything? And I think the idea behind that, and I personally do believe that in the future, those paths may take us to a point where you may be able to deploy a first-class game on-chain. That's my personal opinion. But until we get there, in lieu of that future, no matter how far, we at Apian are attempting to solve the problem today and now. So let's take a look at where the Apian team went from these barriers and how they were solved. So something's still missing here, right? And that's the use of a peer-to-peer framework to allow eventual asynchronous on-chain consensus. All right, so what you need to take from this sentence, again, we're going to do a little dissection, is, of course, peer-to-peer. So Apian is a framework that allows and exposes the tools for its users to create peer-to-peer games. But in addition to what you're used to normally with peer-to-peer in letting everybody bring their own compute power to run the game, in addition, now each user will bring and participate in the consensus mechanism of the game itself in the group. And what that accomplishes, it will allow us to take some of that load off of the throughput that we needed on-chain and consensus, and do that in our little peer group here, and at some predefined interval, asynchronously, place that on-chain consensus that we've gone through, those rounds of consensus by ourselves, and put up on-chain, okay? All right, so let's look at some of the benefits that this peer-to-peer framework has granted us. So it allows us to avoid these upfront server costs. I touched on that, right? If you use Apian framework to create a game among peers, well, you no longer need those upfront servers as a single dev or a small dev team, right? All the peers in the group are bringing their own compute power. Forget consensus for now, they're bringing the compute power. So that alleviates that pain point of cost. Now we shift over to the idea that each peer is also a participant or a node in the consensus mechanism itself. And with that, we have instant client finality. So if you imagine, traditional games with a game server, the game server is, solely responsible, the source of truth, and, it will send out information to the clients, and the clients may experience some small drift, right? And of course, if we try to do that on-chain in a, high interaction, smooth game, well, then it's just going to kind of expand that drift. We can achieve this kind of instant client finality of the consensus in the peer group together, comparable to that of the traditional game server, because the source of truth are all the peers participating in the network itself. We all agree on what is true, and it's distributed among the group immediately. So those two are the most important. Right below that, we have limit issues caused by client servers having two different code bases. Again, this is lowering the barrier of entry, right? If you don't have to worry about, if you're using Apian framework and you don't have to worry about having devs that are competent in server and client, lowers the cost, right? Barrier of entry down. This is just kind of an extra bonus. We eliminate the asymmetric trust that's inherently required by client server, right? So whether we're talking about on-chain, whether we're talking about traditional gaming, there's that asymmetric inherent trust between having the two code bases. That's just an extra bonus, but also that's eliminated, right? We're only working with a single code base now. And if we take all those things and put them together, we take the idea that original prompt where we're like, okay, let's make it possible for single devs. Let's make it possible for small teams to deploy the first-class multiplayer, smooth, high-end interaction game. Let's combine that with blockchain compatibility. On top of that, let's add the peer-to-peer framework that will allow the players to not only bring their own compute, but also participate as peers in the consensus network that will eventually achieve this asynchronous consensus on-chain. Let's wrap that all together, and that is Apian, okay? A peer-to-peer framework for game devs. All right? This is our nice one-liner for it. I like it quite well, so I will read it. A blockchain-compatible code framework and protocol for the management of shared data in these highly interactive multi-user applications. So you notice, sans this, it's not really game particular, right? But games are just kind of epitomize this idea of sharing data in this highly interactive, especially multi-user application. And Apian is a framework that will allow this. It's more than that. It's more than a protocol. It's the mindset that we're going to do this without a game server. We're going to do this with just the peers. They will take on the responsibility collectively through communicating the responsibility of the game server. And in addition to that, they will be able to achieve consensus. And the really special thing about Apian, the framework that allows in terms of consensus, is because the consensus code is kept separate from the application programming, but answers the same APIs. This means that any spun-up peer-to-peer network game, you can choose what type of consensus mechanism you will use among the peers, right? This is, just in time, on the fly, on runtime choice of consensus. So if you and your friends want to use a particular consensus mechanism for the whole game, or even just for particular levels in the game or stages in the game, you can tweak that consensus to optimize the balance between, efficiency and throughput and security based on what type of game you're playing and what type of consensus it deserves. So that is one really cool thing about Apian, I'll say. All right, now I'm going to go through the Apian architecture on the high level. This is kind of the everything together, and I'm going to go through and add one by one and describe what's going on here. Okay. So we start out with this kind of simplest data model. You can imagine, what is the simplest data model? If we're talking about a paper game, maybe that's like the board, the pieces, some kind of scoring pad here. And this is what we refer to as the core state, right? Everything can see the core state, everything can query the core state, but nothing can change it. Except the core logic, right? So now we have this extra piece here called the core logic. It is capable of altering the core state. It is the only code that is allowed to do so. And when we pair these together, core logic and core state together, this makes up what we call the AppCore. Now we're going to see this in practice in a second, but what will happen is we're going to have some external flowing directives, these kind of predefined high-level application domain directives that will flow into the core logic if chosen to do so. They will be interpreted by the core logic, and the core logic will execute some very low-level changes in the core state to reflect what those high-level directives were that were sent to it. Okay? Let's take a look. Before we take a look at the actual flow, let's just review the AppCore rules, right? State can be seen and queried by everyone. We talked about that. State can only be modified with these external command, the directives I talked about. State must be serializable, has to be restorable, has to be hashable. And of course, the logic in the, if we looked at the core logic itself, the logic in there must be deterministic, right? There cannot be anything random. The code has to be stochastic, cannot contain stochastic code. All right, so with all of those things in mind in here, the core logic that will interpret those directives, the core state, if you think about it, that's kind of the foundational, everything you would need to kind of run the server logic of the game there. But that's not only what the game is also the client, right? We need the rest of the game, the visual representation, maybe some randomness, how the users interact, and the rest we call the application code. So you can think of the application code in this example of just handling the front-end tasks like rendering the core state to the user, as well as maybe collecting user input as we're all playing this multiplayer game together. It's collecting our user input, it's sending it out to the AppCore, and again, we go through that flow through the core logic, interpreted to low-level changes in the core state. All right, so the one cool thing about that, the thing I talked about of no random behavior inside the core logic, that means that we push any randomness, any stochastic code down into the application code. The same thing that is interpreting user input and transferring it as directives to the core logic. Well, that means if we want to introduce some other randomness, like for example, an AI player, as you'll see later in the demos, well, this is going to be interpreted by the AppCore exactly the same way as user input would be, right? It lives in the application code, collected by the application code and sent out just as a user input. So to the AppCore, it sees no difference between, in this case, a real user player or an AI player. And this is all good and well. Sending commands directly to the AppCore works pretty well for like a single-player application. We could just keep sending commands straight through, but it's not really what we're trying to do. We don't want single player. We want that first-class multiplayer thing. And this is where the Apian instance comes in, right? So we bring in a new component through the framework, the Apian instance, which is always going to be paired with an AppCore, and together referred to as the core pair. What you need to know about the Apian instance is that it is functionally, for the core pair, it is acting as a proxy for what's going to be this virtual Apian group object out here. And this group object is made of all of the peers that are participating in the game, bringing the compute power and the consensus, okay? In a second, we're going to go back to the diagram and kind of show the full flow through it from application code through the Apian instance through the core pair. But before we do that, we're going to take a look at 3 different messages that are expected inside of the Apian framework. So Apian defines these 3 messages that wrap these application directives, right? We talked about the high level or these predefined directives that are being sent in. Now these are the 3 types. We have commands. So commands they tell the app core to apply some kind of application directive to the core state. A command is essentially saying, we've received the directive, the group has decided that this directive should be a command, and it should be reflected through the core logic to the core state. Now, before something becomes a command, it could be a request or an observation. The request itself, I've hit on a couple times, it's from the application code, and it's an ask. It's saying, hey, I have a directive from this client, should it become a command? Right? Should I send this out to the consensus group, and we need to decide, should it become a command? Observations are the same thing as requests. The only difference is they originate from the app core itself, right? So you can imagine, I like to think of this in my mind as, okay, if I have a request, the difference between a request and an observation, request could come from me or an AI, shooting something in a first-person shooter. Maybe I miss and it hits an object and the object is falling and there's some kind of iterative pattern going on where the object falls on somebody. So the object falling may end up being like an observation that is, again, run through and say, hey, this rock fell on what's-his-name head. Should it be a command, right? Should this be the truth? Do we agree this is on the truth? This is the truth. Okay, so let's take a look at the full flow here. If we imagine a request starting out in the application code, whether that be from a user or from an AI player, some randomness, and that request will be sent over to the Apian instance, which, remember, is a proxy for the virtual group. It will be fed into the proxy and distributed among the group. The group will engage in its kind of consensus mechanism and decide which requests or observations should be promoted to a command. And upon deciding that, that command will be sent back out to the instance and fed through the core logic, which will interpret that command in a low-level way to the changes to the core state that we'll see in the game. We can also imagine this not only from our own point of view, but coming in from the other peers. Maybe a full model inside your head, you would imagine many different requests and observations kind of coming in from all sides, from our Apian instance, from the other peer network users' Apian instances. And through consensus, whatever consensus mechanism we have chosen for this group, it will decide not only which ones become commands, but in what order those commands are distributed. And they will be distributed back through each client system. And then they will be fed through everybody's core logic and core state. And since we're all running the same game, we will all see the same source of truth that we have collectively decided on will exist in the core state. Okay, so I hope that I also have a video here of the flow going through you so you can see it in action. At the end of the presentation, there will not only be like QR codes and links so you can go and look at the explainer it's yourself and kind of see it in action, the flow. It's easier to kind of understand when you can see things moving through it. It's a little too slow though, so because I think about 5 minutes, I'm going to go on to the demo itself. Okay. I have one last slide here before the demo to kind of summarize all of the things that the Apian framework brings in terms of tools, libraries. So altogether, these things will, help the single devs, the small devs, avoid maybe 2/3 of the time on infrastructure and support, building all those systems necessary to deploy that first-class multiplayer, smooth, high-end interaction game. It also will present a place to store the game. I won't get too in-depth on this, but essentially, Apian also allows for non-player peers who are participating in the consensus mechanism to also be part of the peer group. And since each peer, whether they're player and consensus or pure consensus, each has a copy of what's called the command log, which is essentially the game itself. So one way to store the game would be if all of us leave and we leave that one peer consensus validator in there who's still maintaining the log, the command log, that would actually still store the game, and we could all then later join back. Or if everybody leaves, we could store it on somebody's local disk or even on just decentralized storage somewhere and rebuild the command log, restore it to where we want in the game and keep playing. Remember, bring your own compute, right? A peer-to-peer framework for gaming. All peers are going to bring their compute. The reason why we don't have to spend all that time and money on building a sole game server. Another cool thing is networking layer. So essentially, Apian, one of the tools it brings is an abstraction of existing kind of networking code without vendor lock-in, so that you're able to interact as just a normal application programmer would expect, instead of having to hire maybe like a networking programmer. So that's it. Also uses existing network code. The app is shared across the peers, and it's running the same. So when those commands are distributed back through, everybody sees the same thing reflected in their own personal client, and that collective client finality, right? Collective client finality. Consensus is achieved through our agreeance. So when it's redistributed back out, what we have decided is true, it's immediate as soon as we agree, right? All right, and now to the demo, which this is the part I've been trying to get to pretty much all day. The most fun is you guys will be able to see me play the first game created with the Apian framework by Jim Barry himself, the chief architect of Apian, and it is called Beam. So I think I'm going to get a couple people out in the crowd. Are you guys ready? You're on Pokey Hedgehog, right? Okay. All right, let's see if this works. Where are you at, mouse? Okay, here we go. All right, so here we go. I'm going to go through the settings really quick. I only have a minute or two left, so just to show you some of the possibilities here. We have our P2P connection, the choices of our P2P connection, the choices of chain. I have my in-game account versus my permanent account. I have Apian network that's set up here, and then of course I have my screen name is Keith. That's my name. I believe this matches your guys' information, right? We're on the same place. And I'm connecting. Let's see. Okay, I'm getting a let's see. So that's exactly what we're going to do. We're going to see. Okay.
So while he's restarting, I'll just say that this is P2P playing. It actually is a couple of machines we have running in here on the Wi-Fi over a couple of mobile networks. There's also a server that is participating in the game with an AI out of New York on DigitalOcean, running Ubuntu. And then there's a Raspberry Pi on a Starlink network in the upper New England part of the US. So we have latencies that are varying between clients in the tens of milliseconds to 100 millisecond plus. All of that gets abstracted away. The client actually runs, Unity build in any browser on iOS, Android, Mac, Windows, Linux. So it gets all of those nice features. It really is meant for people to kind of divorce themselves from having to worry about all of the details for it, but still be able to get a high-quality game, really individual person or small team developing. And Jim Barry has a long career creating P2P flight simulators, other things. So this is sort of, interpretation from a real game developer of like what is one very interesting possible future, which obviously is different than creating a blockchain RPC. It can work with it as well. But so anyway, that's the context on the network. I'll give it back to Keith.
All right, and so I believe that is time. Yeah? Okay, sorry. So I believe that looks like Jim right there. But yeah, that is time, and I'm just going to put up real quick, if I can, the QR codes and stuff. Is that fine? Yeah? It's going to have to be fine. Yeah, I found him earlier, but I didn't have time to get to him and kill him. But so here you go. If you want to scan, we have a couple different QR codes here. The apianframework.com, us at Mesh here, and then we have another Mesh R&D event later on the 3rd from 12 to 2 at Rhino. Okay.
All right, thanks.